Hi everyone, my name is Carolyn Agie Anak Datu from EC1101D and my student ID is 2020879818.
Hi, my name is Megan and Supang. My student ID is 2020616972 and I am from group EC1101D.
Hi, my name is Veronica Rujeh. My student ID is 2020839186. I'm from class EC1101D. And this is our video presentation of MAT183 for Assessment 3. So firstly, what is differentiation? Differentiation is one of the main topics that we learn in Calculus 1. Another term for differentiation is derivative. This topic allows us to learn how to calculate the rate of change of a function with respect to its variables. Another is, we use this in order to find the slope of tangent line. Being able to understand and apply differentiation in solving mathematical problem also allows us to calculate the maximum and minimum value of a function. However, what is the application of differentiation in our daily life? Let's discuss an example. Encik Mutu is a gardener. He plans to enclose a rectangular garden. The fencing costs 30 ringgit per meter for two opposite sides and 50 ringgit for the other two sides. The rectangular garden has an area of 84 meters square. Find the minimum cost of the fencing.
So here are the list of the important information stated in the problem statement. First of all, Encik Mutu wants to enclose a rectangular garden. Next, we know that the fencing cost is Rm30 for the length of rectangular garden represented by X, whereas Rm50 for the width that is represented by Y. So the rectangular garden has an area of 84 meters square. Therefore, find the minimum cost of the fencing of rectangular garden.
So, before going to the method solution, here are a few things. Dx will be the length of the garden in meter unit, and y will be the width of the garden in also meter unit, while c will represent the cost of constructing fence for the garden in RM Ringgit Malaysia.
So now we can start with the method of solution on how to solve the problem statement. So firstly, we are going to apply the formula for area for triangle, which is length multiply with width. So we let the length be x and the width be y. Yeah, so it will be A represents area equals x times y. Then we will substitute the area of the rectangular garden into A, which is 84 meters square. Then lastly, we will write the equation in terms of y. So it will be x equals 84 divided by y. So now that we got x equals 84 divided by y, we can find the cost of fencing garden. So we will use the formula, which is we multiply the cost of materials, which are 30 ringgit and 50 ringgit with length x and width y respectively. Then from the equation earlier, which is x equals 84 divided by y, we substitute into x. Okay, so to minimize the cost, we have to use differentiation. So we differentiate the equation and multiply the whole equation after differentiate it by y square to cancel out the y square. And then we will solve the equation to get y. And the y we get is 7.0993. So now we can differentiate the equation for the second time. After you differentiate it for the second time, we will get 10,080 divided by y cubed. Then next, we substitute the y value into y. So the y value we got just now is 7.0993. Then we calculate it, we will get 279.705. As you can see here, 279.705 is larger than 0, therefore it is minimum value. Okay, so lastly, to find the minimum cost of fencing the rectangular garden, we have to substitute the value y into the equation. We already got the value y, which is 7.0993. So after we substitute in and calculate it all, we will get 1,419 ringgit and 83 cents. Therefore, the minimum cost of fencing the rectangular garden is 1,419 ringgit 83 cents.
Here are the conclusions for our assignment. Maximum and minimum value are basically applied in our daily life, whereas to find the highest or lowest value in a problem. So, all maximum and minimum problem must include the second derivative test to know that whether the value is positive or negative. If the value is positive, then the applied problem is minimum, where the value is more than 0. While for the negative value, the applied problem is maximum, where the value is less than 0. Therefore, before any calculus or other mathematical techniques is used to solve the applied maximum and minimum problem, the situation needs to be understood and translated into mathematical terms first.
So that's it for our assignment. Thank you.